like when we graph it? Yeah, parabola, right? Okay, kind of U-looking shape. So the most basic of the parabola, where is its vertex? 0, 0. So we can start with that point. No, not if I don't have the pen. Okay, so 0, 0. And then from there, if we weren't sure, some of you probably already know this shape well enough that you know each of the other things. But to help us understand the transformations today and to keep that connection from like the stuff you do with the algebra should match what's on the graph, we're going to use tables to help us do that. So you guys know 0, 0. And if you didn't know the other points, okay, you could just plug them into the function and see what you get if you forgot. So when you plug 1 in, 1 squared is just still 1. Okay. When we plug in 2, 2 squared is going to end up being 4. When we plug in negative 1, the entire thing is being squared. Negative 1 is x. So it's like having negative 1 squared, which means it's negative 1 times negative 1, which goes back to being positive 1 again. And then the same idea with negative 2. It would give us positive 4. So if we plot those points, that's how you kind of get the U shape. Kind of like absolute value, but absolute value acts like a line, so it has like two sides that are V-shaped. This one grows a little bit faster, right? It doesn't go 1 and then go up 1 over 1. The next time when we jump to 2, we go all the way up to 4, and if we went to 3, we'd go all the way up to 9. So it just starts growing faster and faster. So that's what's creating like the U instead of a V. So we get something like this. Okay. So each time that we study one of these functions, we're going to make sure that we understand these things over here. Okay. So like when we give you a test on this, you can expect to have to graph some functions with transformations once we're there and answer all these questions about it. Those are the things you're expected to know about the functions. Okay. So the first thing we want to know is the HK, which is referring to like the vertex point. So you guys already told me the vertex in this case is 0, 0. Now again with the x and y intercepts, we're going to fill them in for the parent function because we can nicely see them. But when we do some of the more complicated ones, we're going to save the intercepts for kind of the end of our unit and go back and review all the ways that you solved in Algebra 1 and in Algebra 2 to figure those out. Okay? But here, what is our x-intercept since we can view the parent function and it's simple? Where does the parent function hit or cross the x-axis? 0, 0. Okay, and what about the y-intercept? 0, 0. So every time it hits the origin, we have the same x and y intercept because those are crossing there. What would be the domain for this function? All real numbers. You can still plug in any value and get a result, or you can see from the graph, you can pick an x way over here. It'll have a point on the graph. It'll just be really high up. Okay? All right, what about the range? Good, 0 to infinity. So y is greater than or equal to 0, or I like the fact that she's using kind of an interval notation thought because we should have learned that. So remember, there's two ways to write these. We can write them as inequalities, or we can write them as intervals. So y being bigger than or equal to 0 means from 0 to infinity, and it is hitting 0, and we can't actually hit infinity, so we use that open circle. If you put a parenthesis instead, yeah, so a parenthesis would mean that this was like an open point, like that you went all the way up to 0, but you never actually got the value of 0. So anytime that's filled in, you want to use the bracket part. But since infinity can't technically ever be reached, that's why it gets a parenthesis. And our real numbers would go from negative infinity to positive infinity. Okay. All right, we're going to come back to the increasing and decreasing interval. Okay, is it 1 to 1? Okay, so to be a function, remember, means every input has one output, right? And you have to pass the vertical line test. This, so it's a function. To be 1 to 1 means not only do you meet that requirement, but you meet it the other way around also, meaning every output only came from one input. So to get a y value of 4, only came from one x being plugged in to get 4. But to get our y value of 4, one x is created an output of 4. 2 and negative 2. So is it 1 to 1? No. So remember, visually to be 1 to 1, not only would it have to pass that vertical line test that tests for a function, but it would essentially also have to pass this horizontal line test idea. Okay? So this is not 1 to 1. Is that okay? So if you have to make a note next to that again, so make a note next to the 1 to 1 that basically would have to pass like the vertical line test and the horizontal line test, both of them. Or if you like to understand it the other way better, it has to meet the definition of a function and the other way around, like for the outputs to only have one input also. All right, what would the axis of symmetry be? Okay, so it's at 0, and then we have to be careful how we describe it. You guys saw once you start learning asymptotes and stuff, we have to know whether you're talking about a line that's going this way or a line that's going this way. So just saying 0, I understand what you guys mean because I'm having a conversation with you right now. But when you write on your paper the axis of symmetry, you're talking about a line, right? And you need to label it with the equation of a line. So if you're talking about a line that goes right here, you're right that it crosses through 0, okay? And what would the equation of the line be? X equals 0, because remember, on this line, every x coordinate would be 0, and those equations are telling us that. So the axis of symmetry is that equation x equals 0. What is the minimum value of the graph? Good. Okay, and notice she didn't name a point. She just said 0. When they say minimum value, are they talking about x's or y's? Y's. Okay, and basically your range is kind of telling you right here. If your range goes from 0 to infinity, this is the smallest thing you reach. Okay, and then it just keeps on going forever. So we're just kind of listing the y coordinate of that vertex point. So the minimum value is just 0. We don't have to list the whole point because when they say minimum, they're implying up and down, and we know they're talking about y values. What about the maximum value of this graph? You have the right idea. So we basically just say none, because look at your range. We said that it goes 0 is the smallest thing, but what's the largest thing? Infinity. Is infinity a number that I like point to on my graph and be like, oh, right there, it hit it and it stopped? No. So basically it's going on forever, meaning does it ever reach one maximum value? No. So it has none. So that is okay to say. All right? All right, so then we're going to go back to the increasing and decreasing intervals. So when you decide these, the first thing you want to do is you want to kind of look at your graph from left to right and think about if you were walking on the graph from the left side to the right side, would you be going like downward down a hill, like decreasing, or would you be climbing up a hill, like increasing? So if I'm on this graph from left to right, the first thing I'm doing is going like this. So would this be considered increasing or decreasing from left to right? Abby? Good, decreasing. So this is a decreasing portion of the graph. Okay. This guy is kind of like neutral. It's like I get a break from downhill, uphill, because it's like the point where it turns around, right? And then after that point, this portion of the graph would be considered increasing. So before we write it, because there's kind of two aspects to this. One is actually understanding how to look at the graph and know this part is increasing, this part is decreasing, whatever. And then the other part is how to write it correct mathematically with notation. So first of all, are there any questions on just establishing what's increasing and what's decreasing? You really have to look from left to right like you're reading a book. Otherwise, clearly the perception would be totally different if you went the other way. So when you're doing it, you really just have to look in that one direction or it's going to get confusing. Don't look like, oh, well, wait a minute, you called this decreasing and the arrow's going up. Yeah, because I was reading it from left to right. And if I was going on that graph from left to right, I was going downward. Okay, so you really just have to think about reading it left to right. To write the intervals, you are writing the domain that these happen in. When I say domain, then what type of values am I paying attention to on the graph? X values. Okay? And they're called intervals, so you're going to use this kind of notation. Okay? So you guys told me this part of the graph is decreasing. We have that correct. But now to list it for me correctly as the decreasing interval, you need to name the domain in which the graph decreases. So basically, you need to write in the form of an interval. You need to tell me my graph is decreasing from forever to the left until I hit 0. Okay? Abby? Good. And because it's to the left side, we're going to call it negative infinity. I get that there's no real negative or positive value to it, but it just lets people know where we're coming from. So from negative infinity to 0. Now 0 is part of our graph, but is 0 part of the decreasing interval? That's hard to answer, right? If it is part of the decreasing interval, it's also part of the increasing interval. Because it's the actual point where you turn around and it's like the lull from going up to down, we don't include it in either. It's like the turning point. It is something separate than being going down the hill or going up the hill. So we end it with a parenthesis to not include 0 because 0 is kind of the neutral point. We're not going to call it part of the increasing or part of the decreasing. It's like the flat part. Okay? Is that all right with everybody? All right, so now we know that 0 is our neutral point, and then this branch of our graph increases. So our graph, if we look at the domain part, if we're looking at the x-axis, our graph is increasing from 0 on forever as we continue across the graph. So how am I going to write my increasing interval? Aiden? Good. 0 to infinity. And again, both parentheses. The infinity is a parenthesis because we can't actually reach infinity. The 0 is a parenthesis because I don't want to include it in one specific interval because it's kind of my rest between increasing and decreasing. It's kind of the flat point. Okay? So these get really confusing because people put y here because it's called increasing, decreasing, so you're thinking about going up and down. But again, it's kind of two separate parts. Look across the graph, kind of like I did in the orange here, and establish what's happening where. But then when you write it out for people, you really need to list it in domain. That's how it's listed. So if you list the other things, it would be completely incorrect. Like people wouldn't know what you were talking about. Everybody good with this idea? Okay. All right, so this is the only function that we're graphing for today. You guys are going to graph some in your homework. We're going to do one of them together and then give you guys the remainder of the time to work on it because we're asking you to do them in a specific way. If you were really good at transformations last year, this is going to be really fast for you. If you struggled with them, this might give you a different way to think about them that hopefully will make you better. Okay? So those of you that have the packet, it's after the graphs. It's on the homework page. And those of you that don't have the packet, this is tonight's homework, okay? So these 8 questions. And what you're going to do is you're going to graph them, but for each one, you're going to make a table of the parent function and then a table for the transformation. Okay. So you just have it listed. After you flip through the quadratic and cubic, there's like a page with like 3 things listed. Just look for the title that says practice with individual transformations, okay? But you'll do them on a separate sheet. So here's what you guys are going to do. Your normal parent function, so this part's going to be the same for every single problem that you do. So if you want, you could just put this table at the top of your paper, okay? We made this input-output table when we were graphing the parent function that gave us these points. So does everybody understand where I got this table from? The one we just made when we made the parent graph. So I'm saying all of these are based on that because they all have x squared in them, right? So let's say I go to do number 1. What has changed about number 1 from the parent function? The -3, right? Is the -3 happening after you complete the function or before? So what I mean by that is your function is squaring. That's what a quadratic does, right? If you're doing something to x before you squared it, then you're going to have to change the x's. If you're doing something after the number has already been squared, then you're really changing the y values of this chart, because this is the number before being squared, and this is the number after being squared. So when you look at number 1, that minus 3 that's there, is that happening before the number is squared or after? After, okay? Which means which coordinate is it really adjusting from our table? The y coordinate, okay? Because the squaring is going to happen like normal. I'm going to get this number, and then I'm going to adjust it, okay? How much is this number going to be adjusted according to the equation? Minus 3, right? So my new table for number 1 is going to include this transformation. Does that make sense? The x's are not being changed, but the y values are all having 3 subtracted from them, which means in my table, I would have these same values for x, but the y value would be the original y value subtracted by 3. Okay? So here, this is no longer going to be 4. It's going to be 4 minus 3, which turns out to be 1. And this is going to be 1 minus 3, which turns out to be negative 2. And 0 minus 3, which turns out to be negative 3. And 1 minus 3, which turns out to be negative 2. And 4 minus 3, which turns out to be 1. Is that all right with everybody? That's all I have. All right, so then we want to get this on the graph. So that means if I want to graph what number 1 is saying, I'm now going to graph these transformed points. Okay, so instead of graphing the point negative 2, 4, my graph's going to have the point negative 2, 1. Okay? So then you would create your graph. And then I would just plot these points. So negative 2, 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, 1. Oops. So what effect did that minus 3 have on our graph overall? What did it do to our picture? Abby? Yeah, it did down 3. So if you want to make some notes about that, if you're not as strong as you were last year, or you didn't really understand this last year, basically you want to make the idea that that minus 3 is moving this down 3. Okay? And then it just asks you for domain and for range. So the domain here is still all real numbers, okay, or negative infinity to infinity. And then the range here is from negative 3 and above. So y is greater than or equal to negative 3. Or our graph goes from negative 3 to infinity. Like that. Okay? Is this all right with everybody? Okay, so then the one thing that you guys have to be careful of, who remembers what was tricky in Algebra 2? Which transformation is a little bit, like, they're mostly what you see. So like number 1 was subtracting 3 from the y coordinate. What's going to happen in number 5? Add 2 to the y coordinate. Okay? What's going to happen in number 3? Times 2 to the y coordinate, because the 2 is not inside with the x part of what's being squared. You wouldn't times by 2 till after you finish squaring, right? So anything that doesn't happen until after you finish squaring your function is something you're going to do to the y coordinates. Okay, so in number 3 would times by 2, and what would happen in number 7? Times by a half, the y coordinate. What would happen in number 4? Times negative 1 to the y coordinate, right? All of these so far are outside the squaring. And number 8, you would times the y coordinate by negative 2. Now, I skipped number 2 and number 6 because they're a little bit trickier. Does anybody remember what happens when that minus 3 is inside with x being squared? Yeah, Chase.
So I remember that if it's negative, you have to go to the right. Like if you move the graph to the right instead of to the left.
Yeah, good. So the formulas for these have x minus h in all the formulas. Do you guys remember this? So this minus makes it really weird. That means if h is a positive number, Like if h is positive 1, your equation says x minus 1, but your h is really positive 1, okay, which moves your whole function to the right 1. So what is your h value in number 2? So the h value is positive 3 because the formula already has a minus sign in it. The minus sign is part of the formula. So the number after the minus sign is your transformation. The number after our minus sign in number 2 is a positive 3. Does that make sense to you? Or else it wouldn't say minus anymore. So that's really adding 3 to the x coordinate. Okay, so make a note on that if you have to, that number 2 is really like adding 3 to the x coordinate. So what's going to happen in number 6? Yeah, it's really like subtracting 2, even though it says plus 2 because the formula has a minus. So for them to get a plus in that equation, they had to put a negative number after that minus. So that plus 2 really means their h was a negative number, and that's why we say it's really going to the left 2 or subtracting 2 from the x coordinate. Okay? Do you guys understand what you're doing for tonight's homework? So basically, just like we did here for number 1, you're going to do that for each of them. You can just keep this chart on the top of your paper. You don't have to rewrite that chart over and over again for each problem, but that's the one you're referring to make the transformations. Okay?